So this is a nice problem describing a lot of what we've learned, both in our two-dimensional force unit and our circular motion unit. And like any other force problem, you start with a free body diagram. So we've got a car following a roughly circular turn. And at least in this dimension, the only force we have, because it's following a circular turn, is we must have a centripetal force, an inward force. And the force that keeps your car on the road from skidding out is friction. And if it's not skidding, it's static friction. So what we now need to do is basically make our sigma F equation. And we'll include along the radius, our only force is FFRS. Since we're moving in a circle, the centripetal acceleration applies. So A is V squared over R. So this might be a discouraging sight to see so far because of this equation, we don't have an equation for, we don't have a value for frictional force. We don't have a value for mass. We don't have the speed, we're trying to find it. The only thing we have is the radius. But if you're in this situation, just keep going. Keep plugging in anything you can and just keep trying to simplify it until something pops out. So it would be worthwhile looking if we do have an equation for static friction force. And we do. Let's look at our equation sheet. So we see that the force of static friction is less than or equal to mu s Fn. Now the less than or equal to is kind of a warning sign to us. It means we should be careful because if it's not an equation, we can't use it. If the force of static friction is less than mu s Fn, that means we're not about to slip and the force of static friction is just as big as it needs to be. We have to look for extreme language, like as fast as you can go, or the maximum speed, or the maximum angle, or something that suggests that we are really at the limit, and that the force of static friction is equal to mu s Fn. So let's check. I do see some extreme language here. It says this is the fastest that we can possibly go. So I'm comfortable saying that the force of static friction is the coefficient of static friction, Fn. So the only thing we need now is the normal force. And we can't really do the normal force in this picture because it's straight up. So what we need to do is really draw from the side. And you get to see how bad I am at drawing a car. That is literally the worst car I've ever drawn. I apologize. But we do have our normal force going straight up from that picture. And of course, gravity going straight down. So if we do sigma F along the y-axis, and sometimes this is actually called the z-axis for straight up and down. It doesn't really matter. It's clearly perpendicular to the radius. We have our usual Fn minus Fg, and we don't have any up-down acceleration. So Fn minus Fg is 0, and Fn is equal to Fg. We now actually are on the verge of solving the problem because we know that the force of gravity, we do have an equation for that. It's mass times 9.8, or mg. So this problem, which was just unsolvable, as long as we kept going and looking for anything we could plug in, could we plug in an equation for static friction? Could we plug in an equation for the normal force? As long as you keep going, it'll work. So let's substitute in. And we have mu s mg is mv squared over r. Before we plug in now, the mass is on both sides of the equation. So that means we can divide it out and it should cancel. And we're left with mu s g equals v squared over r. It's kind of significant that mass cancels. What that means is that it doesn't matter whether the car is fully loaded or nearly empty. It doesn't matter whether it's big or small. The road has got an equal maximum speed for all vehicles like that, as long, of course, as the coefficient of friction is the same. So yeah, we could plug in at this point. You won't believe how long it actually took me to figure out from Google Maps how wide that turn was. I was sitting there measuring with a ruler in Microsoft Paint. Yeah, let's solve that. So 7.6 times 0.8 times 9.8. And then we'll square root it. So I've got 7.72 meters per second is V. So no matter the mass of your car, that's as fast as you should take that turn, assuming this is the coefficient of friction between your tires on the road. I know that looks challenging. I promise you can do it. Remember, you bite the elephant one piece at a time. Picture sigma F equals MA along the radial axis. List whatever forces you got and just keep trying to plug in. Keep trying to plug in. If you get the normal force in there somewhere, do a sigma F along a different axis. Good luck.